Hello. So this is our lecture for voting theory. Just note that I may divide this lecture into two parts because I like to keep each video about 20-25 minutes long. So I'm going to try to do that. And if that means I have to put two videos for voting theory, then I think that's better than one long video. All right. So what you can see on your screen is basically some notes that were made from our textbook, Math and Society. So if you follow along the textbook, you'll see these same examples, or I'll also post these notes so you can have them also, but they are basically directly from the book. So, all righty. So voting, right? I'm going to assume that everybody knows what voting means. But if you've never thought about it before, there actually are quite a few different ways that you can vote and decide on something. So that's what this is about. We're going to kind of look into that. Okay, so section 1 is voting methods. So let's begin. Let's talk about preference schedule. Hold on, I got to get my controls under control here. All right, here we are, preference schedule. All right. So a preference schedule is made from preference ballots. So, a ballot is what you get if you're going to mark your ballot, that's you voting, but a preference ballot is where you rank all of your options. So not just picking one out of however many options you have, but you rank them like first choice, second choice, third choice. And then once everyone's ballots are in, the people who are responsible for counting the ballots, they often will make a preference schedule, right? So a preference schedule is a list that shows how many people voted for each preference order, right? Because like say, whatever your choices were, say there are 3 choices, whatever your first, second, third are, there's probably a lot of other people who have the same preference as you, right? Same first, second, third choice. So the preference schedule is when you gather all of those together and say, okay, there were this many ballots that had this order, and there were this many that had this order. Okay. So let's do an example. Maybe that will help. So we have a vacation club is trying to decide which destination to visit this year. Are they going to go to Hawaii, which is symbolized by the letter H, Orlando O, or Anaheim A, right? And what they have here, let me zoom in a little bit, make this easier to see. What we have here are all the preference ballots, right? So we've got Bob input his ballot. His first choice was Anaheim, his second choice was Orlando, and his third choice was Hawaii, right? And then Anne, her first choice was Anaheim, but her second choice was Hawaii, and her third choice was Orlando. So each of these people are the people that voted. Okay. And you can see that, let's see if we can find, does anybody have the same preference as Bob? So Bob was AOH. Is there anyone else? It looks like he was the only one that had that preference. Is that true? Yeah, I'm not, make sure my eyes aren't flimming. Yeah, I think so. So he was the only one that had A first, then O, then H. What about Anne? She had AHO. Anyone else had that? Oh yeah, so here's Eve also had that same preference. Jim did too, and I think those were the only 3. So those 3 people had the same preference ballot, right? So the second part of this is to take that list of preference ballots and complete the preference schedule. You can see this here, complete the preference schedule by determining how many votes were cast for each option. All right. And so you look at, so this part was already made for us, but if we had to make that, we would look at all the possible orders that were voted for, right? You don't have to use all the possible ones, because if nobody voted in a certain order, then you don't have to put that on your preference schedule, right? But let's just take Bob. We know Bob did AOH. So there's AOH right here. And we had already looked at that, and nobody else had chosen that particular preference schedule, right? He was the only one. I'm gonna double check one more time. Yeah, he was the only one that had Anaheim first, then Orlando second, then Hawaii third. So there was only one of those. So it looks as if like they're asking us to complete the preference schedule, so we have to write down how many of each kind of each order there were. So I might just write here, there's just one. There was only one of that preference. Okay, then let's look at Anne. So Anne had AHO, so Anaheim, then Hawaii, then Orlando. And as we saw, there were a few others. So Anne had that. Whoa, my screen's flicking out. Eve had that. Jim had that, and I believe just those three. So 3 people had that preference order. So we would put a 3 here. All right, now let's look at the next one. That was Mary. So Mary had OHA. How many other OHAs were there? There's one. There's one. I think just those 3. So there were 3 of these. And then, of course, the rest of them have to be HAO, but let's count them anyway. That's Alice, Lupe, and Tish. All right, 1, 2, 3. So that would be 3. Now I'm going to double check real quick. Let's count. There were how many people voted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these numbers here should add up to 10 because we should count them all. So let's see if that is true. 3, 6, 9, 10. Yes. Okay. So that is the preference schedule. It just tells us how many people voted with each preference. Now we haven't actually done a complete voting method yet, right? That's just establishing what a preference ballot and preference schedule is, because we are going to use that in some other voting methods. Okay, so let's talk about our first method called plurality. All right, so we are right here, the plurality method. Okay, so I'm going to scroll up past our preference schedule stuff. All right, so the plurality method, right, is where you give people a preference ballot, they vote, and then the person with the most first place votes is the winner, right? So a pretty simple, straightforward method. So here are just some points about this method, right? You could have ties, even if you only had 2 choices, right? If you had an even number of people voting, you could have a tie. So you'd have to figure out some way to break a tie. There's lots of ways you could do it. It's possible for a winner to have a plurality, right, without a majority. So if you remember, majority means more than 50%, so more than half. So if you have more than 2 choices, you could have a winner that did not have the majority vote, but they got the plurality, meaning more people voted for them in their first place, but they still don't have more than half the votes, which may or may not be a problem depending on, you know, what you think. And then the issue here is that the person, the candidate, whatever, with the most first place votes may not actually be the one preferred over the winner by the majority or a lot of the voters. So if you look in the textbook, there's a deeper discussion about that, and it's pretty interesting, and it brings forward this idea of fairness criteria. So like things that we think voting methods should conserve if they're going to be fair, right? And we'll talk about those later, but you can read about them in the book too. So let's just do some examples to see if we can work out like who would win using the plurality method. All right, I'm going to scroll up. So remember that plurality is the person with the most first place votes is declared the winner. Okay, so here's the example. All right, so you have 3 candidates running in an election for county executive, whatever that means, right? Goings, McCarthy, and Bunny. That's how I'm going to pronounce those. These names actually, if you look in the book, they come from an actual elections. There's a link there in the textbook and you can go see that. So I'm going to pronounce them Goings, McCarthy, and Bunny. I'm actually probably going to do G, M, and B, right? And so here we have the voting schedule, so the preference schedule below. So let's take a look at this. Let me zoom in just a little bit. We can see that, hold on, that's better. 44 people have this preference schedule, right? So that Goings was their first choice, Oh, it's McCarthy. Is that it? McCarthy was the second choice and Bunny was their third choice. So 44 people voted in that preference schedule. And so on and so forth. Notice that there are two columns where there is only a first choice. So that means that those people didn't bother to rank the other candidates. They just said, no, I want Goings, and then I don't care about anything else. So we just don't know what those ballots would have chosen in their first, second, and third choices. All right, so the question is, which candidate wins under the plurality method? So we just have to count who has the most first place votes, right? So we are going to look at the first choice row, and we're going to count which candidates have how many votes. Okay, so we see that, I'm just going to put G, that's Goings. We can see that he was first choice in 44 ballots and 14 ballots and 20 ballots. So we would just add those up, right? 44 plus 14 plus 20. I'm going to write that down. So let's see. We have to add those together. Should I try and do that in my head? No, I will not do that. I will not make you suffer. So I'm going to just get out my calculator. That way I don't have to introduce the error, my own errors. 44 plus 14 plus 20. All right, this is 78. If I typed it in right. So Goings had 78 first place votes. All right. Now what about McCarthy? That's M, McCarthy. So we can see that McCarthy had 70 ballots where they were first place and another 22. So that's 70 plus 22. Ooh, that's more than Goings. So that I can do in my head. That's 92. All right. And then the other one is Bunny. Let's put Bunny here. And how many did they have? They had 80 plus 39. 80 plus 39. What is that? I'm going to do that on my calculator just so 119. Oh, look at that. So according to this preference schedule, Bunny is the winner. And it's B-U-N-N-E-Y. Yeah. B-U-N-N-E-Y wins, right? They have the most first place votes. There were more ballots with Bunny in the first place choice than any other candidate. Okay, so not too bad, right? A lot of counting. All right. Let's see. By the way, this example was one of the try it nows in your book. So there's another example in your textbook, and then there's a try it now, and that's what this example is here. All right, let's see. What's the next example? The homeowners association is deciding on a new set of neighborhood standards for architecture, yard maintenance, etc. 4 options, A, B, C, and D have been proposed. So they're just numbered, labeled A, B, C, and D. We don't know what they are. And the votes are, okay, I see the preference schedule there, and then they're saying find the winner under the plurality method. Okay, so we know the situation. I'm going to zoom in to the preference schedule here. Okay. So we've got, let's just make sure we understand, right? There 8 people voted first place for option B, then C, then A, then D. Okay, 9 people voted for this, 11 voted for that, right? We know what a preference schedule is. Okay, so we want to find the winner under the plurality method. So when we do that, we look at just the first choice row, right? Because we're just counting first choice votes. That's what plurality means. Okay, so we have 4 options, A, B, C, D. A, B, C, and D, and we need to count the first place votes for each of them. So let's see. For A, right, we've got A is here and here. So A has 9 plus 7 first place votes. All right, that is 16. When you zoom in, the ink gets really large. Okay. What about for B? B is here and here. So they have 8 plus 7 first place votes. That's 15. All right, and C, you can see, C is right here. They only have 5. And D is here with 11. Okay, so clearly A has received the most first place votes. So A is the winner, wins. A wins under the plurality method, right? Okay, so not too bad, right? If you have your preference schedule, you just have to count number of first place votes to see who wins under the plurality method. Now, in these examples, there were no ties, so we didn't have to worry about that. But what if there is a tie of some sort, or what if you want to go a little more in depth? Oh man, I forgot to start my timer. Now I don't know how long this video was. Okay. Well, I'm going to assume it's been about 10 minutes. Okay. All right. So instant runoff voting, IRV. So also called plurality with elimination, right? So I'm going to scroll up here so I have room. Here we go. Okay, so there can be some issues with preference ballot voting, and you can read about them in the book, right? So instant runoff voting is one way to try and work with some of those issues, right? So it's called instant runoff because you know what a runoff is. Sometimes if you have an election and there's a tie, then you have to have another election to choose who wins over the tie, right? Sometimes it's called a runoff vote. But with instant runoff voting, you collect preference schedules, so you already know people's next choice. So if there's a tie, you can already see who they would have chosen next, and so it's kind of like an instant runoff. You already have the information you need to sort of choose between. Okay, so instant runoff voting or plurality with elimination. So this is how it works, right? So you gather the preference ballots and you make the preference schedule like normal, right? But then you go through and you look, and the choice with the least number of first place votes is then eliminated. Okay, so they were chosen, they had the least number of first place votes. So you kind of say, okay, we're not even going to look at them anymore. And any votes for that candidate are redistributed to the voter's next choice. Okay, so you can see that's why it's like you're eliminating you're doing like an elimination, right? You're saying, okay, these people have the least first place votes, so they're going to be eliminated. But then those votes, go to the next choice of those voters. I'm just thinking about that, thinking, does that seem like a reasonable thing to do? I mean, I suppose, because they have to go somewhere. So let's see. So then you just keep doing that until somebody has a majority, so over 50%. Okay. So there is an issue there. You can read about that, right? It says when voters change their vote to increase a candidate's chance of winning, it can actually result in the candidate losing, which is a very interesting paradox. And they actually discuss it more in the book. So let's do an example so you can just see an example of how this works. Okay, so notice how this example number 4 is the same preference schedule we looked at before with the Goings and McCarthy and Bunny. And if you remember, we had already determined, let's go back and see what we had there. Here we go. Yeah, we had Goings had 78, McCarthy had 92, and Bunny had 119. So let's write that down. All right, we had Goings, McCarthy, and Bunny. I can't remember already. 78, 92, 119. So 78, 92, 119. Let me just double check. 78. Yeah, okay. And so if you're using just plurality, we had decided that Bunny would have won, right? Because they had the most first place votes. But now we're doing plurality with elimination or instant runoff voting. So that's a little bit different. Now, if you remember, it said that with the plurality with elimination, you're going until somebody has over 50%. So it might be kind of nice to be able to see what percentage of votes each of these candidates got. So in order to do that, we have to know the total number of votes. So we would just add all of these numbers, right? Because those are counting all of the different preference schedules. If you add those all up, that's telling you how many voters there were. So let's just do that real quick. So 44 plus 14, I'm using a calculator, plus 20 plus 70 plus 22 plus 80 plus 39. That's 289. Oops, trying to write with a highlighter. Okay, so that's 289 total. So if we wanted to determine which percentage, now I'm going to do this just for fun, but we don't actually have to know this information. But we can see, right, each percentage, if you take for goings, 78 divided by the 289, right? If you take 78 and you divide it by 289, let's see what we get. You get 0.26989. So as a percentage, right, that's about 26 point, I'm going to round, I don't know. That's about 20. I'm going to round up to 27% because that's very close, right? So that's about 27%, right? And then McCarthy got 92 out of 289. That gives me 0.3183. So that's about, I'm going to round that up to 32% just because it's easier to write, right? And then Bunny, 119 out of 289, 0.4117. So that's nowhere near 42. So I might say that's about 41.2%. Okay, so that's just a quick review of how to take a count out of a total and make a percentage. So we might want to think about that when we're doing our method here. Okay, so we want to find the winner using instant runoff voting, not just plurality. Okay, so when you do that, you take the preference schedule you were given, and you take the person with the least first place votes and you eliminate them. Okay, so we already know that Goings was the person with the least number of first place votes. So we're going to take our preference schedule and we're just going to cross off wherever Goings is there. And then if anybody is below him, we're going to move them up. So that's what we're going to do here with our blank preference schedule. We're going to write a new one. Okay, so the number of votes doesn't change. So still we're leaving these numbers the same. So 44, 14, 20, 70, 22, 80, and 39. Okay, and now we're just going to rewrite the preference schedule without any G's. So everybody moves up if need be. So that means here we're going to have M and then B, right? So those 44 first place votes get shifted down to the second place winner because we've eliminated Goings because Goings had the least number of first place votes. And so for this one, it's B and then M. And then for this one, these 20 people only gave us a G. So that means that we are just not going to consider those at all. I mean, there's nowhere for them to go. There's no second place option. So those 20 votes are eliminated, which also means that our total is going to change. So we have to pay attention to that. The total number of votes that we're now considering is not the same 289 as it was before because of that. All right, these 70 votes are now M and then B. The 22 are also M and then B, so be aware of that. That's okay. The 80 are B and then M, and those 39 are still B. Okay. So now notice we only have 2 candidates left, so one of them is going to be the winner. So now we need to count how many first place votes each one of those has. And then even though we should, I mean, clearly the person with the most votes is going to be the winner, but we're still going to calculate the percentage just so we can see. Now, if there were more than 3 people, you would definitely want to calculate the percentages and see if anybody has a majority, because if no one has a majority, then you need to do this again, right? You don't just pick the person with the greatest number of votes. You want to eliminate until somebody has a majority. Okay. All right. So what do we got here? Let's do the new total first. So that's going to be, it's going to be 289, but minus that 20. So that's going to be 269, right? Because 8 minus 2 is 6. Okay. And now let's look. So how many votes did McCarthy get first place? So let's add these up. We're going to add up the 44 The 70 and the 22. All right, that's 136. Let's see, out of 269, that's that's just over 50%. So that's 50.56%. So that clearly is a majority, right? So we could stop there and say, yay, McCarthy has won. But just for fun, let's count also Bunny. Bunny has how many first place votes? 14 plus 80 plus 39. That's 133. Oh, so close. And what is that percentage? Divided by 269. 0.4944. So that's about 49.44%. So very close, but indeed McCarthy has won using the plurality with elimination, aka instant runoff voting. So notice, right, we did this, took the same preference schedule, and with plurality, Bunny won, but with instant runoff voting, McCarthy won. So the way you choose your winner definitely can affect who wins. So that's kind of important. Oh my gosh, I forgot to, my timer turned off. Okay, well, we'll be all right. Let's see. So hopefully that was pretty clear how we did it. Let's do another one. We'll do another example where we do plurality with elimination or instant runoff voting. I prefer the name plurality with elimination for some reason. Let's see. So this is a different example. Zoom in a little bit here. So I'm going to scroll up, get rid of what we just looked at. All right. The homeowners association. Oh, okay. So this is the homeowners again. They're deciding on the new stuff for their homes there. We have 4 options. And here is the preference schedule. So I believe that is the same preference schedule that we looked at in the other example. Okay. Trying to see, is this a question in the book? I don't know. Maybe, maybe not. I hadn't really looked. Well, okay. So they're saying find the winner under the instant runoff voting method, also known as plurality with elimination. Okay. So here we have, they don't give us any pre-printed charts or anything. We just got to do it. Okay. So let's see. How do I want? So we know, first of all, let's count how many total votes there are just for fun. We want to add this up. So I'm going to zoom in a little bit here to this preference schedule. If we add these, again, trying to write with a, if we add these all up, right, the total is, boom, 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 8 plus 9 plus 11 plus 7 plus 7 plus 5. That's, I get 47. Let me double check. 8 plus 9 plus 11 plus 7. Okay. So that's 47 total votes. Good to know. Now let's see. Who got the least number of first place votes? I think we can just look and see that C here had only 5. D had 11. And then A had 9 plus 7. And B had 8 plus 7. Okay. So C had the smallest number of first place votes. Okay, so we are going to eliminate C from this preference schedule. So I'm just going to go here. I'm just going to cross out all the C's. Did I get them? Did I get them all? I believe so. Okay. Now, if you wanted to, you could then draw another preference schedule, but I think I can do it just by crossing them out. Now I can see, right, like if I look, say, here at this column, I can see now that D is going to have those 5 first place votes. So I'm not going to worry about drawing it again, though you could if you want. I think I'll be able to see that, below the crossed out C, that whoever is there gets those new votes. Okay. So I suppose we could see who has what at this point, because now we are left with, we only have A, B, and D. And so let's count how many first place votes each of those has after that first round of elimination. All right, so A it looks like A still has 9 and 7, which is 9 plus 7 is 16. B still has the 8 and the 7, which is 15. And D now has these 11 and these 5. So that's 16. Okay. So I don't know if anybody has a majority yet, but there is a tie. So I think I'm just going to go and do another round of elimination. So let's see. I might just label this like after first elimination. That's what we get. Okay. So let's do it again. B has the smallest number of first place votes after that first elimination. So let's get rid of all the B's now. B. Did I cross them all out? I think so. Okay. So now we have we're considering A and D. So after that second after second elimination, this is what we've got. All right, how many first place votes does A have? All right, A gets these 8, these 9, and these 7, and these 7. All right, what do we got? 8 plus 9 plus 7 plus 7. All right, that's 31. All right, and then the D gets the rest of them. So what is that? That's 9 plus 11 plus 7 plus 5. 9 plus 11 plus 7 plus 5. Right? Yeah, because D is above. I'm only adding the ones where D is above the A. Wait, why did I give? Oh, looky there. I tried to give D those votes that A got. So that's not good. So that's why I'm double checking, right? I should only be adding the ones where the D is above the A. And for some reason I did. So don't include that one. That is not right. So it should only be the 9, the 11, and the 5, because those are the only places where the D is above the A, which means they are first. Okay. So 9 plus 11 plus 5, and that's it. So that's 25. Now let's double check that these two numbers, let me write them down, that these two numbers add up to 47, because they should. And that's another way I would have caught my error. Like if I had, for some reason, double counted those 7 votes, then when I checked if I had the right number of votes, it would have been off. So that's another way. So you should always be double checking your work, right? So 31 plus 25 is indeed, that's not 47. Why? Oh, dang it. I did it twice. I counted the votes under A twice. I missed it this. Okay, so this one also, this one right here, that is not, I counted that one. That was below A. I guess, I don't know. My eyes were just saying, oh, there's a D, I should count it. So there you go. So there is a very good reason to make sure your counts are right? So I should have only circled the D's that were actually above the A's. Okay, so now the 2 D's that are circled in purple are indeed above the A's. I haven't counted those votes for A and then tried to count them again for D. So for those of you that had already caught that, that's good job. So it's really just 11 plus 5, which is 16. Okay, so now 31 plus 16 is indeed 47. Okay, so now I've got it right. All right. So clearly A has won, right? Let's calculate percentages just for fun. So 31 divided by 47 is, this is 0.6595. So I'm going to do a little, that's about 66%. And 16 divided by 47, that's about 34%. Okay, so when we already knew that A would have the majority, well, I guess it's possible. I mean, there's only 2 candidates, so if they happen to have the same number of votes, then no one would have a majority. But the difference between these number of votes is big enough that we definitely knew A was winning. Okay, so we say that option A wins. Under the plurality with elimination method. Do you remember who won under the other method? I can't recall. I just want to go see. Oh, A also won under. So in this case, it's the same winner with both methods. That's kind of nice. Okay, so that is plurality with elimination. All right, so even though my timer stopped, I stopped my timer by accident. I think I'm going to end this video here. So this is just a portion of the voting theory. In it, we have covered what a preference ballot and a preference schedule is, and some examples of finding who would win if you're using the plurality method, and then the instant vote off, also known as plurality with elimination method. All right, I will see you in a few moments for the board account. Okay.